At the dawn of this century, astronomy began to see our solar system in a new light. In 2017, we were startled by Oumuamua, the first confirmed interstellar object. 2 years later, 2I/Borisov followed on a hyperbolic track, demonstrating that our planetary neighborhood is permeable. Now, astronomers have detected 3I/ATLAS, an object that defies expectations. It appears larger than typical comets, follows a trajectory that might keep it within our sun's grasp, and displays brightness that cannot be explained solely by reflected sunlight. What could it mean for our scientific models if a cosmic interloper refuses to obey the usual rules? This video explores the data surrounding ATLAS, weighs different interpretations, and invites you to decide whether we are witnessing a natural phenomenon or the first hints of extraterrestrial engineering.
Chapter 1. A Date with Destiny.
When a comet plunges toward the sun, it normally slingshots around and disappears back into interstellar space. Atlas, however, may not follow this script. On 29 October 2025, the object will pass behind the sun, and its path could convert from hyperbolic to elliptical, effectively parking it in our solar system for years, or even centuries. Recent observations estimate its nucleus is around 5 to 6 kilometers across, yet its mass seems far higher than a body of that size should be. Astronomers note an unusual ratio of carbon dioxide to water ice in its coma, and a brightness that some argue originates from within. Do these anomalies signify that Atlas is a relic from a particularly exotic protoplanetary disk? Or could they point to something constructed? As you listen, ponder whether such coincidences can be explained away, or require new categories in our taxonomy of celestial objects. Harvard astrophysicist Avi Loeb highlights the improbability of interstellar objects appearing so frequently. Statistically, bodies like Oumuamua, Borisov, and Atlas should be separated by tens of thousands of years. Yet we have detected 3 within a decade. Loeb argues that either our estimates of interstellar debris are badly flawed, or some of these objects may not be inert debris at all. He points to ATLAS's nearly perfect alignment with the ecliptic plane and its proximity to several planets as a hint that its path might not be purely random. If you were sending a probe to explore another star system, wouldn't you steer it toward the plane where most of the planets orbit? This line of reasoning is controversial, but it forces us to examine our assumptions about the cosmos and consider that we may not be alone in shaping trajectories through space. Chapter 2. Mass, Composition, and Secrets. As Atlas draws nearer, astronomers refine their measurements. Early estimates place the nucleus at roughly 20 kilometers across. Subsequent observations revised this down to about 5.5 kilometers. Nevertheless, its mass is enormous, at least 33 billion tons, based on the minimal non-gravitational acceleration, despite notable outgassing. What would it mean for a comet to be both massive and yet exhibit such unusual behavior? One possibility is that the object is porous and lightweight despite its size, like a honeycomb. Alternatively, the composition could include metals or manufactured materials that change its density and response to forces. Think about that. A comet made partly of metal or hollow structures. Does that sound like nature or engineering at work? The enigma deepens when we examine the chemical makeup of ATLAS. Unlike typical comets, dominated by water ice and dust, 3I/ATLAS has been observed to contain unusually high ratios of carbon dioxide relative to water ice. Infrared spectrometry hints at exotic molecules that are rare in standard cometary chemistry. Are we observing the remnants of a primordial protoplanetary disk from a distant star? Or something that formed under conditions we have not yet imagined? Some researchers propose that the volatile chemicals could be trapped inside cavities created by engineered structures. Others argue that unknown natural processes in other star systems might produce such compositions. Either way, the diversity of interstellar objects challenges our assumptions about what is normal in space. Mass and composition are not the only puzzles. The orbit of Atlas takes it close to Mars on the 3rd of October 2025, a rare opportunity to capture high-resolution images with the Mars Reconnaissance Orbiter. Planetary scientists hope to glimpse details of its nucleus and perhaps detect jets of material or even unnatural features. What might we see when we look more closely? If the object deploys a probe or changes course near Mars, it could suggest active control. Should we interpret that as benign exploration or a potential threat? These questions may sound like science fiction, but they are grounded in real observational scenarios we will face in a matter of months. Another intriguing aspect is the timing of Atlas's approach to perihelion, the point where it is closest to the Sun, on 29th October. When the object is obscured behind the Sun, Earth-based telescopes cannot track its exact motion. This communications blackout is the moment some speculate that Atlas might perform a maneuver, using the Sun's gravity to slow down and adopt a bound orbit. Is this simply anthropomorphic projection, imagining intentions for a lifeless rock? Or is there a genuine possibility of deliberate course alteration? Observations from the ESA's JUICE spacecraft and other missions in 2026 will be critical to determine whether the comet remains hyperbolic or becomes captured. Until then, we can only watch and debate. The hyperbolic path of ATLAS might also tell a story about where it came from. Dynamic models suggest that it may have originated in the outer reaches of the Milky Way, perhaps in a cold interstellar cloud. But its near alignment with the ecliptic could imply that it was ejected from a system similar to ours. If interstellar debris is evenly distributed, why would this object follow a plane similar to our own solar systems? Some astronomers caution that observational bias, our instruments are more sensitive to objects near the ecliptic, could account for this. Others maintain that the trajectory is too precise to be mere chance. Your interpretation may depend on whether you believe the universe is inherently random, or if hidden patterns hint at deliberate design. Chapter 3. Natural comet or engineered vessel. At the heart of the debate is whether ATLAS is a natural comet or an engineered vessel. Proponents of the natural hypothesis point to its coma and tail, which appear similar to those of other comets. When frozen gases thaw, they create jets that push material away, forming a diffuse cloud. Hubble Space Telescope images have shown such activity around ATLAS, suggesting a volatile, rich body. Yet the brightness and spectral properties are not entirely typical. Could a manufactured object mimic cometary behavior to evade detection? If we discovered a craft disguised as a comet, would we even recognize it? Our assumptions may blind us to anomalies hidden in plain sight. Consider the propulsion techniques available to an advanced civilization. Chemical rockets would be impractical for interstellar journeys. Instead, theoretical concepts such as light sails, nuclear fusion drives, or gravitational slingshots could accelerate probes to significant fractions of the speed of light. A craft employing such methods might appear inert, coasting for millennia between stars. It would not display the obvious thrust of a rocket engine. So if an alien probe passed through our neighborhood, would we misclassify it as a comet simply because we expect engines to look like those of our own rockets? This question cuts to the core of our limitations. We interpret observations through the filter of our technology and experiences. Even if Atlas is natural, its anomalies can teach us important lessons. Oumuamua lacked a visible coma and exhibited non-gravitational acceleration, leading some to propose that it was a thin, sail-like object. Borisov, on the other hand, looked like a typical comet, but with exotic composition. Atlas seems to bridge the gap, presenting both a coma and unusual chemistry. What does this diversity tell us about the processes that shape planetary systems across the galaxy? Perhaps our solar system is not as representative as we thought. Each interstellar visitor may be a messenger, carrying clues about distant worlds and inviting us to expand our theoretical horizons. Skeptics argue that invoking alien technology is unnecessary when natural explanations suffice. Occam's razor, a philosophical principle favoring simpler hypotheses, suggests we should assume natural causes unless compelled otherwise. But Loeb counters that we should not shy away from investigating the extraordinary. Scientific progress often stems from questioning accepted models and considering improbable alternatives. If evidence points to something unprecedented, shouldn't we follow it wherever it leads? Dismissing possibilities without rigorous examination could cost us the chance to make one of the most profound discoveries in human history. One of the main criticisms of the technological hypothesis is that it can encourage sensationalism and undermine science. Some worry that focusing on extraterrestrial probes will attract conspiracies and distract from careful analysis. Yet the same fear existed when people first proposed that meteorites came from outer space, or that germs cause disease. Where is the line between skepticism and closed-mindedness? Genuine inquiry requires us to entertain unusual ideas without falling prey to fantasy. By testing each possibility, we refine our understanding of the cosmos and ourselves. As this chapter draws to a close, we leave you with a question. If tomorrow an object were incontrovertibly identified as an alien probe, how would society respond? Would our governments work together to communicate, or would fear dominate? Our readiness to answer may reflect our ability to face unknowns with courage and curiosity. Keep this in mind as we proceed to the next section. Chapter 4: The Loeb Scale and Global Collaboration. To systematically evaluate interstellar objects, Avi Loeb proposes a new classification system, informally known as the Loeb Scale. It ranks objects based on how likely they are to be technological rather than natural, considering factors like unusual brightness, non-gravitational acceleration, trajectory alignment, and chemical composition. An object scoring above 5 on this scale would warrant international investigation. Do you think such a scale is necessary, or is it a publicity stunt? Proponents argue that a structured framework could help scientists allocate resources and avoid knee-jerk dismissals. Critics worry it might lend undue credibility to wild claims. This tension illustrates how new ideas challenge existing paradigms. Loeb also advocates for a coordinated global effort to monitor and respond to interstellar visitors. Currently, The discovery and observation of such objects rely on scattered surveys and ad hoc collaborations. He envisions an international organization akin to the World Health Organization, but for space anomalies. This body would pool data, fund missions to intercept objects, and develop protocols for potential contact scenarios. Would you trust an international panel to speak for humanity if we encountered an alien probe? Some fear that national rivalries could impede cooperation. Others argue that facing cosmic unknowns requires unprecedented solidarity. The future may depend on our ability to transcend borders when facing interstellar mysteries. The Loeb scale and calls for cooperation draw criticism from several quarters. Some astronomers worry that the media attention will sensationalize ordinary comets, undermining public trust in science. They emphasize the need for rigorous peer review and caution. Meanwhile, Loeb argues that ignoring anomalies because of fear of ridicule slows progress. Is it better to risk embarrassment by exploring fringe possibilities, or to risk stagnation by adhering strictly to conventional wisdom? History shows that paradigm shifts often begin with controversial ideas. However, not all controversial ideas are correct, so discerning which to pursue is a delicate balance. When we talk about global collaboration, we inevitably confront political and social challenges. An interstellar object raises issues of security, resource allocation, and cultural significance. Some politicians may view it as an opportunity to demonstrate technological superiority or to control information. Others may fear panic if the public perceives a threat. Who gets to decide how we respond to cosmic visitors? Should the process be democratic, scientific, or driven by national interests? Without clear structures, miscommunication and mistrust could spiral out of control. Establishing transparent protocols now could mitigate chaos later. This chapter encourages you to reflect on the infrastructure we currently have to detect and handle interstellar anomalies. Are we prepared to recognize and study objects that defy our models? If not, what should we build to improve our readiness? By fostering open dialogue and cooperation, we increase our chances of making sense of cosmic visitors. Will humanity rise to the challenge, or will bureaucratic inertia and narrow-mindedness prevail? The answer will shape not only how we understand 3I/ATLAS, but also how we confront future unknowns. Chapter 5. A Turning Point. Perihelion Maneuver and Mars Flyby. Chapter 5 brings us to the critical period when Atlas approaches its perihelion and passes near Mars. As the comet draws near to the red planet on the 3rd of October 2025, the Mars Reconnaissance Orbiter will have a once-in-a-lifetime chance to image it up close. High-resolution photos might reveal whether the object is spherical, elongated, or irregular. They could detect potential vents from which gases escape, or, in a more speculative scenario, structures that appear geometric or artificial. If we see unexpected shapes or patterns, how will we interpret them? Will skeptics downplay anomalies as artifacts of imaging? Or will believers trumpet them as evidence of extraterrestrial engineering? This flyby may fuel debate for years. The concept of a perihelion maneuver adds further drama. At its closest point to the Sun on 29th of October, Atlas will be invisible to Earth-based instruments. This creates a window of opportunity for the comet to change its orbit without immediate detection. If Atlas slows down, it could remain in the solar system. If it continues on its path, it will leave forever. Does the idea of an object altering its orbit on purpose sound plausible or too fantastic? Natural forces, such as outgassing, could modify the trajectory slightly. However, a large deviation might suggest active control. After perihelion, radar observations and missions like JUICE will check whether Atlas's speed and direction have changed significantly. The results will either quell or intensify speculation. Another fascinating speculation concerns the possibility of ATLAS deploying smaller probes. Some imagine that as it passes Mars, it could release a small craft to survey the planet, or even remain in orbit. While no evidence currently supports this, the notion sparks questions about interstellar exploration strategies. If an advanced civilization wanted to study many worlds efficiently, would a single large vehicle with deployable probes make sense? On Earth, our own space agencies use motherships and landers to explore multiple targets. Thus, applying similar logic to hypothetical alien technology is not unreasonable. Even if unlikely, considering such scenarios helps us think creatively about what interstellar missions could entail.
Throughout these discussions, it is vital to balance speculation with evidence. Scientists will examine changes in ATLAS's velocity, direction, and brightness to determine whether any anomalous behavior occurred near perihelion or the Mars flyby. Meanwhile, popular media may seize on any irregularity to claim proof of extraterrestrial craft. As a viewer, how will you differentiate between rigorous analysis and sensational headlines? By looking at data, peer-reviewed studies, and credible sources, we can evaluate claims critically. Our goal is not to jump to conclusions, but to encourage curiosity and maintain healthy skepticism.
We close this chapter with an invitation. When October arrives, and news outlets start reporting on ATLAS's approach, how will you engage? Will you follow the scientific updates, join discussions online, or simply marvel at the cosmic drama unfolding? You, the viewer, play a role in shaping the conversation. By asking thoughtful questions and sharing credible information, you can contribute to a more informed public discourse. The next section will explore deeper philosophical and practical implications of long-term interstellar visitors. Chapter 6: Existential Questions, Preparation and Contact. Beyond the immediate curiosity about ATLAS lies a broader existential question. How should humanity prepare for potential contact with an interstellar probe, whether natural or artificial? Our species has no established protocol for communicating with extraterrestrial intelligence or responding to unknown technologies. Some scientists believe we should send a message, while others warn that broadcasting our presence could invite danger. If an interstellar visitor lingered in our system, would you advocate for reaching out or staying silent? The answer may reveal your optimism or caution about the unknown. Philosophers and astrobiologists speculate about the motives of hypothetical aliens. They outline three broad possibilities: exploration, resource acquisition, or defense. A probe could be an autonomous sentinel, scanning star systems for signs of life. It might harvest materials or energy. Or it could act preemptively against perceived threats. Which of these motives seems most plausible to you? Our perceptions are colored by human history. We project our own colonial, exploratory, and defensive behaviors onto others. A truly alien intelligence might operate according to motivations we cannot fathom. Recognizing this limitation encourages humility in our interpretations. Preparation for contact involves more than speculation. Some scientists propose building dedicated telescopes and satellites to monitor interstellar visitors. Others suggest developing artificial intelligence to quickly analyze anomalies and coordinate responses. International dialogue is necessary to craft policies for communication or defense. If tomorrow an interstellar object showed clear signs of technology, do you trust current world leaders to handle it wisely? Would you prefer decisions to rest with scientists, politicians, or a public vote? Answers to these questions reveal underlying faith in institutions and experts. Another angle concerns cultural and psychological preparedness. Contact with an alien probe, even a non-sentient one, could have profound effects on religion, philosophy, and identity. Some might feel exhilarated, others fearful. Our stories about aliens range from utopian cooperation to dystopian invasion. Do these narratives shape how you react to the idea of ATLAS being a technological artifact? Recognizing our biases can help us respond more rationally if we ever encounter evidence of extraterrestrial technology. We must ask ourselves whether we are ready to adapt our worldview when confronted with something truly alien. At this juncture, we invite you to engage directly. If you were part of a global committee tasked with drafting protocols for interstellar contact, what priorities would you set? Would you emphasize scientific curiosity, caution, public transparency, or security? Thinking through these priorities helps us anticipate the ethical dilemmas ahead. By participating in this thought experiment, you contribute to a conversation that may one day move from hypothetical to practical reality. Chapter 7: Scientific Skepticism and Intellectual Humility. The discussion around ATLAS exposes deep divides within the scientific community. Many astronomers insist that there is no need to invoke extraordinary explanations when ordinary ones suffice. They emphasize the importance of statistically sound models and warn against confirmation bias. Others, like Loeb, call for entertaining unconventional ideas while maintaining rigorous evidence standards. Where should the line be drawn between healthy skepticism and dismissive closed-mindedness? It is one thing to demand evidence. It is another to refuse to investigate because the hypothesis feels uncomfortable. Understanding this distinction is vital for scientific progress. One reason for reluctance to consider alien technology is the stigma attached to UFO-related topics. For decades, stories about unidentified flying objects have been associated with conspiracy theories and pseudoscience. Serious scientists fear that engaging with such topics could harm their credibility. Yet in recent years, even governments have begun to acknowledge unusual aerial phenomena. Does the ridicule surrounding UFOs hinder legitimate research into anomalous objects like ATLAS? Moving forward may require rebranding the field, focusing on data and avoiding unsubstantiated claims. In doing so, we can separate serious investigation from sensationalism. Intellectual humility plays a key role in navigating these controversies. Recognizing the limits of our knowledge allows us to entertain new ideas without surrendering rigor. Throughout history, many discoveries, such as the germ theory of disease or the existence of other galaxies, were initially ridiculed. Could today's speculations about interstellar probes be tomorrow's accepted science? Possibly, but only if we remain open to evidence and adjust our views accordingly. Humility does not mean believing everything. It means being willing to update beliefs when faced with compelling data. An example of skepticism evolving into acceptance is the story of exoplanets. For centuries, scientists speculated about planets around other stars, but only in the 1990s did we obtain concrete evidence. Initially, claims were met with caution, But as detection methods improved, thousands of exoplanets were confirmed. Will interstellar objects follow a similar trajectory of skepticism giving way to discovery? The more we look, the more we may find. Atlas is part of this ongoing exploration, challenging us to refine our instruments and models. As we weigh evidence and speculation, it is helpful to ask ourselves, what kind of evidence would convince you that ATLAS is an artificial object? A change in trajectory? Detection of engineered materials? Radio signals? Clear images of geometric structures? Knowing what would persuade us helps clarify our expectations and guard against confirmation bias. Being explicit about the criteria for extraordinary claims enables a more productive conversation. In closing this chapter, we encourage you to remain curious, skeptical, and humble. Ask questions, evaluate sources, and be willing to change your mind. The mystery of 3I/ATLAS may or may not reveal alien technology, but the process of inquiry enriches our understanding of the universe. Are you ready to follow the evidence, even if it leads to uncomfortable conclusions? The next chapter will discuss our long-term future with interstellar visitors. Chapter 8: Long-term implications and the cosmic perspective. As we approach the end of our journey, we broaden our perspective beyond ATLAS itself. Interstellar objects serve as reminders that our solar system is not isolated. With potentially dozens of such visitors passing within Jupiter's orbit at any given time, each one carries information about the environments from which they originate. What can these messengers teach us about the diversity of planetary systems and the likelihood of life elsewhere? Studying their composition, trajectories, and interactions with solar radiation enriches our understanding of astrophysical processes. The continued discovery of interstellar objects may lead to new theories about star formation, planet building, and the distribution of matter in the galaxy. If Atlas or another interstellar object were to remain in our solar system, it would become a long-term subject of study. Future missions could send probes to rendezvous with it, sample its material, and perhaps even land on its surface. Such missions would provide invaluable data about matter from another star system. Would you support funding these explorations, knowing that the payoff could reshape our understanding of the cosmos? Balancing scientific ambition with economic reality is a perennial challenge. Yet the potential discoveries, from novel chemical compounds to possible evidence of technology, may justify the cost. Long-term visitors also prompt us to consider the possibility of surveillance and observation by other intelligences. Some hypothesize that probes could linger in stable orbits, monitoring planetary systems for eons. Others suggest that interstellar debris might occasionally deposit microorganisms, seeding panspermia. How does the idea of being under observation affect your view of humanity's significance? Such reflections can inspire both awe and humility. Whether or not we are being watched, the vastness and complexity of the universe make our existence seem simultaneously precious and precarious. We are part of a cosmic story much larger than ourselves. When we imagine a future where interstellar objects become commonplace, we must also grapple with the ethical dimensions of interacting with them. Should we attempt to capture or exploit such bodies for resources? Is it moral to alter their trajectories, knowing they originate from other star systems? Would mining an interstellar comet be akin to harvesting a natural resource? Or could it be considered cultural appropriation on a cosmic scale? These questions may seem fanciful today, but as technology advances, they will become relevant. Building ethical frameworks now can guide responsible decision-making later. As we reflect on these ethical considerations, we realize that our responses to interstellar visitors mirror how we treat one another and our planet. Values such as stewardship, respect for the unfamiliar, and curiosity drive both environmentalism and the search for extraterrestrial life. Do you see a connection between caring for Earth and preparing to engage with cosmic neighbors? In both cases, humility and foresight are essential. By thinking globally and cosmically, we may develop a more holistic ethic that transcends species, planets, and even star systems. The long-term presence of interstellar objects also challenges our notions of time. Many human endeavors are planned over years or decades, but cosmic processes unfold over millennia. How do you feel about participating in projects whose results may only be known by future generations? Engaging with interstellar objects invites us to think in deep time, beyond our lifespans. Such thinking can inspire projects like long-duration space missions, archive preservation, and intergenerational cooperation. Accepting the responsibility to act for the benefit of distant descendants is a sign of maturity as a species. Conclusion, a final reflection and call to action. We have traveled far in this exploration of 3I/A TLAS, from the specifics of its trajectory and composition to the philosophical questions it raises. Whether Atlas turns out to be an ordinary comet, a rare natural oddity, or evidence of advanced technology, it has already served a powerful purpose. It has inspired us to question, to debate, and to imagine. Are you satisfied with the answers we currently have? Or do you feel compelled to learn more? The mystery remains unresolved, and that is a gift. It urges us to look up, to ask questions, and to expand our horizons. The conversation does not end here. Instead, it begins anew every time a curious mind engages with the cosmos. We also leave you with a final challenge. If you are fascinated by the mysteries of the universe, if you love pondering interstellar visitors, cosmic origins, and the possibility of alien intelligence, then make your voice heard. Like this video, leave a comment with your thoughts, and subscribe to our channel for more deep dives into space, science, and beyond. Your engagement helps us produce content that explores these profound questions, and it fosters a community of curious minds. Together, we can push the boundaries of knowledge and keep the spirit of exploration alive.